Hey everyone, I'm Pine and welcome back to my Screeps Nooby guide. Today we're gonna talk about container mining. Before we do so, though, I have to show you a few changes I made in the code since the last episode. The first thing I changed is how I look for towers, because I only look for towers in one specific room, which is obviously not very useful when you have multiple rooms with towers, so I changed that. The only line I changed for that is this one. This is the line where we look for the towers. So what we do now, instead of looking for towers in one specific room via the room.find function, we use the game.structures variable, which gives or returns us all the structures, or all our structures, or my structures in this case. And then we use a Lodash function, dot filter. Lodash, if you forgot, I think we used it before, is a bunch of functions for JavaScript, which are useful mostly for arrays and lists and stuff like that, or collections in general. So the Lodash dot filter function is filtering through a list or an array and looking for a specific condition to be met. So the condition in this case, or the first parameter is the array we give it, which in this case is game.structures, the array it should look through, and the second parameter is the condition it should met. And there are multiple ways of using this function. The way I prefer using it is with an arrow function. So we define an arrow function here that acts as a filter. So this arrow function takes s, which in this case will be a structure, as an input parameter, and then returns a Boolean value defined by this statement. In this case, this is s.structureType is equal to structure tower. So this will return all my towers into this variable, in this array here, and then we iterate over the array as we used to before. So nothing complicated here, but I wanted to mention it because it's not super obvious how you find all your towers in the game actually. So it took me a while to figure out what the best way of doing is. I think this is the easiest way of doing it. Anyway, the other thing I changed, I added a my here. So this was the creeps in room variable was used where it was defined with find creeps, and that's actually not good when there is an enemy in your room, because then it will return an error later down the line, because the error will not have a memory with a specific role, or at least not one you can access. So yeah, you want to change this to find my creeps. It's not terrible if you don't well, actually it will break your code when there's an enemy in the room, I think. Yeah, so yeah, change that. And the other thing I changed is a little bit of logic thing. You don't have to change that, and I sometimes swap back to the old behavior as well. I changed this line, which is the default behavior when we don't, we have enough creeps for every role. Then I, usually I was like, okay, then just build another builder if we have full energy. And that causes some issues, especially in low-level rooms, because sometimes you just get way too many builders, and yeah, you will not, you will not have enough energy to supply them all anyway. So it doesn't make sense to do it, because it will cost you a lot of CPU. So yeah, I tend to change that line and basically remove it and replace it with name is -1. The name is -1 is only important, so my check down here for the output message is actually working properly. So basically I'm setting it to an arrow. I didn't spawn a creep this time. If you just leave it undefined, then we will get an error here somewhere. So that's not great. So yeah, just replace this with this if you want to. You can keep the old line as well though, especially if you're higher level, it should be fine. But when you make a new room, then it will spam your room with builders, so that's not great. So I tend to do this and just define the number of creeps statically with the memory variables, and it will not just adjust it. So this means, however, that you will overflow energy from time to time. So that's not optimal, but I will address that next episode. Not this one, but next one we're going to talk about storage. I have to figure out how that works first though, so it will be another few days, I guess, before I do this. Today though, we're going to talk about container mining. So what is container mining? Well, container mining is a specific form of static mining. There are multiple ways of doing static mining. There's drop mining, container mining, and link mining, and probably another variant someone found. So static mining means that instead of having a harvester going to a source, harvesting it, and then bringing the energy somewhere else, you have a creep sitting at the source and moving and harvesting the energy and not moving. So it will drop the energy somewhere, either in a container, on the ground, or in a link, depending on the method you use. So basically, the idea with container mining is, and drop mining as well actually, But let's talk about drop mining first. So because that's easier. So when the creep is harvesting more energy than he can carry, for example, because he has no carry pods whatsoever, or your code is just written in a way that he will not stop harvesting even if his carry is full, then the energy will be dropped to the ground below the creep. And if the energy is on the ground, other creeps can pick it up. And that's what's called drop mining. So basically you set a creep with no or very low carry parts on the source and just a few work parts and let it harvest the source as for its whole lifetime without moving away. And it will drop all the energy on the ground. Okay, here comes container mining. Containers are basically little storage buildings, which, however, are walkable, similar to a road. So creeps can walk on a road. They can also walk on a container. They can even walk on a container which is on a road, which is a little weird, but anyway, you can do that. So now, if you have a creep sitting on a container and harvesting energy, and it will drop energy because it doesn't have any carry parts, the energy will be dropped right into the container. And now other creeps can pick up the energy from the container and bring it somewhere else. Link mining is if you have a link next to the creep, and the creep will actively put the energy into the link. Downside of that is you need some carry parts, and you have to actually move the energy into the link. With the drop or the container mining, you just harvest it and don't worry about it. It will just drop to the ground or in the container. So for drop mining versus container mining, the difference is, if energy is lying on the ground, it will decay over time. So it's not super efficient to drop the energy to the ground. The disadvantage of container mining is that a container will actually decay and you have to repair it. So you either have to repair the container, or you have to accept that you will lose some energy because it's just decaying on the ground. So none of them are optimal. But I choose container mining because I don't like the idea of losing energy. It doesn't make much sense because I lose energy by having the containers, by repairing the containers. But still, I like it more. It's more clean somehow to me. So I prefer that. Okay, I built the containers already. Well, the reason for that is actually I had this code running already. So I wrote the complete code because I had to test it. It's fairly complex compared to what we did before so far. So I had to test it a lot, and I had to make sure it works. So I developed it on the main server and built containers for it, obviously, and had it running. And now I reset the code, and we're gonna do it again. Okay, so we have containers already. That's great. We're gonna go with a method that we have one container per energy source because that's usually what you want. In this specific room, I could have one container in the middle of the two energy sources, and just have one miner sitting on it and mine both sources. Yeah, I'm gonna write the code generically, so I will do one container per source. That makes more sense, in my opinion. Okay, cool. So, well, let's talk about the miner first. So the miner is the creep that moves to the container and mines or harvests the source. Okay, so the miner needs one move part because he has to move there at least once. So I don't think there's a way to move it without the move part. It would be nice to have another creep moving it there so you could actually save the move part as well. But I don't think that's a mechanic in the game. Reminds me of, what's the name, Duskers, where you can tow another drone around with your drones. So that would be useful, but I don't think that's a mechanic in the game so far. At least not that I know, but maybe there is a way of doing it differently. Anyway, the easiest way is to give the miner one move part, so he can move to the container. And then he needs some work parts. So it's actually pretty easy to figure out how many work parts you need. An energy source takes 3,000 energy, and it will regenerate every 300 ticks. So basically, it regenerates on average 10 energy per tick. So your miner has to harvest 10 energy per tick to like completely or use the source perfectly or optimally. And one work part allows you to harvest 2 energy per tick, so you need 5 work parts. Okay, so we need a fairly simple creep that is just sitting on a container and harvesting it. So let's write that, shall we? Okay, so we build a new creep or create a new role. So let's just copy, doesn't really matter, let's just take one of them. The claimer, fine. Rename it to miner. And see what we do. I don't think we need that stuff. Let's just delete all of this. We don't need this right now. So okay, first we have to figure out which source are we going to go. And my plan is to save the object ID. Every object in the game has an object ID in the memory of the creep. So when we create the creep, we will tell it, here's the object ID of the source you want to harvest or you want to go mine. So we're gonna do that first. So we get the source. let source be game.get object by ID, which is the function. If you give it an object ID, it will just return you the object. So that's pretty useful because you can't store objects in memory. If you store an object in memory, it will not be in memory. It will not be valid anymore next tick. So what you do is you store the ID in memory, and then in the next tick use the get object by ID function to get the object in the current tick. So let's say the variable is called source ID, and that will give us the source. Okay, now we need the container as well. How do we get the container? Well, that's a little tricky, or a little more tricky. We could store a container there as well, I guess, but I decided for a different approach, which is probably not optimal, but anyway, let's do it this way, because it's the first thing I came up with. So container, what we're going to do is we're going to look for a container right next to the source. There's a semicolon missing here, I think. Never mind. We're gonna fix that in a moment. Maybe we don't. No, it doesn't need a semicolon here. Never mind. I'm an idiot. Ignore the last few seconds. Anyway, so we're looking for a container next to the source. So what we're gonna do is we're gonna use source dot pos, which is the position object of the source, and then use find nearby. I think. No, what's it called? Wait, I have to check the API. I forgot how it's called. Close to? No. There's a function. Find in range, I think it's called. Where's the pos object? Room OOP path. Room position. There we go. There is a function called find in range. There we go. So it takes a type and a range. So we're gonna do that. Oh, it actually takes an options as well. Oh yeah, we can use that. Okay, cool, good. So find in range, and it first takes a type. So we do find structures, and actually, sorry. Actually, I'm not quite sure. Are containers my structures or structures in general? No, they're not owned. So don't use find my structures. You have to use find structures. They don't belong to you. Similar to roads. Which don't have an owner either. So find structures, and then we give it a range, which we will use 1 because we want adjacent, and then we're going to use the optional options parameter to filter the thing for containers. So we're going to do this filter, and use an arrow function again as dot structure type is structure container. There we go. Structure type structure container. Okay, looks good. So this should give us a list of containers next to the source. We only want 1, so we're gonna add this, and there we go. So this gives us the first of the list. There should only be 1. Well, you can set up multiple containers next to the source, obviously, but we just need 1. So we take the first one we find. And now we have to check if the creep is actually on the container. Oh, by the way, for performance, if you're worried about performance, because, for example, because your CPU is running high, you might want to save this container ID, the ID of this container object in memory, and only check for it once. As mentioned earlier, that's probably more efficient, but I'm not going to do that right now because I don't worry too much about CPU right now. So this is not optimal performance-wise, but you can improve it yourself if you want to. My code in general is not very good for performance. It's not optimized for that at all. It's optimized for being fairly easy to understand. If you are worried about performance, then you have to do some performance optimization yourself, I fear, because I'm not an expert at that at all. So here we go. We have to check if the creep is on the container already. So if creep.pos, and now there's a very useful function called pos.equal. For some reason, all my auto completion is gone again. I'm not sure what's going on with here. God damn it. Let's check in the API. What's it called? I think equal to or something along those lines. We're in room position already. Equals to, I think, or is equals to. There we go. Is equal or equals? Equal to. Okay, and now it takes another object, another pos object, so we can go container.pos. However, we can actually remove the pos because the is equal to will will actually, you can give it a position, like a room position object, or you can give it any object that has a room position, because it will just look for that itself. So we can just do this, and actually I think it's easier to understand if I do it this way. So the position of the creep is equal to the position of the container, and if that's the case, if that's the case, we're gonna mine. So we just do the regular creep dot harvest. No, is it harvest? What's the function? Oh, god damn it! I'm always looking up code. Like I cannot remember any function names and stuff. It's harvest, okay. And if the auto-completion is not working, I'm just completely screwed. So I have to look everything up. The harvest. I'm not sure what maybe do I have to do the update thingy once so it actually works for in here? I don't know. Maybe. So creep harvest source. There we go. We don't have to move towards it because we are next to it already, because we're on a container that is adjacent to the source. So we are in range, definitely. If we are not on the container, however, then we are not in range, and then we have to move to the container. Easy as that. Creep move to container. And there we go. Okay, that's a miner. Easy. Fairly easy, actually. Nothing to worry about. Okay, that's included into the main code. Roll. Oh yeah, I'm gonna refactor this code at some point, by the way, or a lot of the code actually. I'm planning, probably the next episode will be about storage usage, and probably the episode afterwards will be about refactoring the whole code, because a bunch of stuff here is not very easy to read anymore because it got so long. Like, this is terrible. You can make this so much easier and or shorter and easier to understand. Yeah, gonna do that at some point, but not right now. So miner, should have just done copy pasting, I think. Anyway, roll miner dot run creep. So now we have to spawn miners. Well, spawning miners is a little bit more complicated because we have to give the miner, when do we want to have a miner? Well, when do we want to spawn a miner? When we have a source with a container next to it which doesn't have a miner already. We can't do it as we did with the other roles, because there's not just a specific number. We have to give them specific source IDs when we create them. Actually, let's do the spawn code first. Prototype spawn. It's really simple, so we just copy this, and there's actually a semicolon missing. You can't, it's not important to be there, but it makes sense that it is there. Anyway, you can ignore it if you want to. And build the crepe. So create miner, and it will be work move. Let's break this down here. There we go. Role will be miner, and oh yeah, it will take a source ID as a parameter. So we do this. There we go. And now we have to spawn it. Okay, so we want to spawn a miner, as mentioned, when there is a source in the room with a container next to it which doesn't have a miner. Okay, so we're gonna put that code here before we spawn the other stuff because it has higher priority. Let's start with looking for sources. So do we have the sources already? I don't think so. No, but we can get all the sources in the room. So we have let sources be spawn.room.find sources. And now we loop over the sources for let source off. Yeah, should be off because it's an array. Sources. And now we check if the source has a miner already. So we're gonna use a lodash function again. So we wanna check if there's any creep with the role miner and the ID of this source as a source ID. So we're gonna use another lodash function which is called lodash.sum. This takes an array and then a predicate, so another condition basically, and it will return a bool depending on if it finds any object in the array which is matching the condition. So basically this reads like, is there some object in this array that fulfills this condition? Okay, so the array will be creeps in room, and now we need condition. We do it with an arrow function again, because as mentioned earlier, I think that's the easiest or the best way. Like, it's the easiest to understand, at least to me. I like arrow functions; they're pretty neat. And we're gonna check for two things. Row is minor, and see the memory source ID is equal to source.id, so the ID of the source. And so this will return true when there is at least one minor with the source ID of the current source. We only want to do something if you don't find one, so we negate it by putting an exclamation mark in the front, which will just negate the Boolean statement and flip it around. So now this condition will be met when there is no minor for the specific source. In this case, we want to spawn one. Well, no, there's another check we have to do. In this case, we want to look if this source actually has a container. If it doesn't, because if it doesn't, we don't want a minor for it. The idea here is that I want to be able to have rooms which are relying on harvesters and just don't use container mining, especially when I get a new room. This might be useful. And but also have rooms which use container mining. So I want to be able to support both with my code. So I'm gonna have to check if the source actually has a container, and I just assume if there's a container next to the source, I want to use container mining. So in this case, I need a miner. So we're gonna check for that right now. So yeah, this is okay. This is a little tricky because the API for this is a little weird. So we're gonna define a variable. And basically what we're looking for is all the structures adjacent to the source. So there's a function called spawn.room.look for at area, I think. Let's open this actually, so I don't screw it up. That's a little weird. This function is a little strange, but no, not room. What did I do? Room object. No, that's not correct. Room. The room. It's down here. Look for at area. So this is a little weird one. Okay, it takes 6 parameters. Well, no, 5. Never mind. No, 6 is correct. 6. So first it takes a type. So we look for a structure. So find structures. Unfortunately, there's no find containers. This would make a bunch of stuff easier. And now it takes 4 numbers, which define the position, the area you're looking in. So basically, this function, what it does is it takes a specific area in a square, or a square area, and in this area, it will look for things that are matching the type, and will return them as a list of objects, which is a little weird, but we're going to talk about that in a moment. First, let's define the area. So we do that by defining 4 points. I'm not sure why it's not defined with just... Oh yeah, no, it's 2 points, but each point has an X and a Y, basically. So top left and bottom right. So top will be... Well, now we want... Which area are we looking for? What do we want to do? We want to... Wouldn't it be easier to just find... Wouldn't it be easier to just use the same function we did here? Find in range. Yeah, why not? That's actually easier. Why did I do this differently? I think for performance reason, probably. Yeah, find in range is pretty terrible performance-wise. Let's do it anyway. It's easier. It's way easier. If you're looking for performance, as I said earlier, then go ahead and optimize this. But I'm just gonna do this. That's way easier. Containers. Well, yeah. So, is there something wrong with it? I don't think so. Stores, find in range. Yeah, we're looking for a container next to the source. Sure, that should work. We just have to check if there are any. So actually, we can do this something again. Okay, this hopefully doesn't go wrong. This is not how I did it originally, but I think this makes more sense. So we do... Well, actually... No, let's make it a little more easier to read. Let containers be source.pause.find in range. There we go. So and now we do if, well, we can just do length. Containers.length. There was a reason I didn't do it this way. Not sure why. Anyway, we'll probably find out if there was a crucial reason. So if there's at least one container next to the source, then we're gonna spawn a miner. So we're gonna go spawn.create miner with the source.id. We just, yeah, of the current source. And we also, oh yeah, we set name to it, the return value. There we go. And we break the loop at this point. So break here will lead to this loop getting cancelled. So we jump out of a loop even if there are more sources left, because we have a spawn command already. We don't have to look for other sources as well, because we have one source already which needs a miner. Okay, and now we have another problem, because this will be overridden. This create miner function will be overridden by the code down here. So we have to prevent that. We do that by just having another if condition around that. So if name, let's just copy what we have down here. Well, no, we can just do it if name is undefined. It's not undefined. So if name is defined, no, we only do this if name is undefined. There we go. That's not undefined. And defined. Okay, sorry, I'm a little confused right now, but it's the most complex topic we had so far in this episode, in this series. So bear with me. So we only want to do the other spawn code, or the rest of the spawn code, if we didn't have any spawn command up here yet. So as soon as we have this line here, as soon as we decided we need a miner right now, name is defined. And in that case, we're gonna skip this whole code, and we'll just jump straight towards the output down here. So if I didn't screw it up, I think I screwed it up. There we go, that's better. Okay, and if name is undefined, yeah, okay. So we only look for new spawn conditions if we didn't had one yet. So if name is undefined. Okay, cool, that's the miner. Actually, if we save this, it will probably spawn miners already, I think. Maybe not. There we go, it does. Spawn 4, spawn a new miner. Cool. Let's actually put the, oh yeah, no, we're gonna do that later. Okay, so spawn 4 is spawning a miner already. Yeah, they're all spawning miners now. Good. Okay, so this works already. Sweet. Cool. Now we need to do two other things. First, we need to create another role which is carrying, or which is filling up the extensions and the spawn. And I'm gonna call that a lorry, because the lorry doesn't need work parts. It just has to pick up energy from the container and bring it to the spawn, to the extensions, and to the tower, basically. So it's doing what a harvester was doing earlier, but instead of mining the energy itself, it will just pick it up from the container. And then we have to adjust all the other roles to take energy from the container if there is one available, instead of harvesting it itself. Okay, so let's do a new role. It will be very similar to the harvester. So we're gonna copy the harvester, rename it to Lorry, and it's actually super similar. So this will all be the same. So the working part will be exactly the same. It will still look for spawns, extensions, and towers and fill them up and stuff like that. The only thing that changes is how we get the energy. So instead of looking for active sources, it's gonna look for a container. So find structures, and is find close by path taking an array, a filter? I think it is, right? Let's check really quick. This is on pause. I think it does. Should be. Find closest by path. It takes options, yeah. So we can put a filter in there. So we're just gonna copy it from the main. We had it here. There we go. There we go. So we look for the closest structure, which happens to be a container, and this will return it. There we go, we get one, and then we tell the creep to not harvest it. Oh, we need another condition as well, actually. So it has to be a container, and it also has to be not empty. So we look for a not empty container. The container doesn't have an energy property, it has a storage property. So we have to do storage, I think resource energy. Yeah, this looks good. So this will return, like, basically the container can store not only energy but on other resources as well. So the storage property is actually an object or an array. No, not an array. Well, yeah, an array with, like, where you can put, yeah, an array, and you can put an energy a resource type as the index, and it will return the number of this, or the value, the amount of this resource the container stores. Well, that was a little confusing, but anyway, this returns the number of the amount of energy this container stores. So we have to compare that to storage capacity or something along, or storage max storage, something along those lines. Let's check really quick. Structure container store capacity. There we go. There's actually an example here which shows exactly that, I think. Store resource energy is... Oh yeah, we don't want to check for full. We want to check greater 0. Yeah, so we don't need store capacity. We just want this. Store resource energy greater 0. We want a container which is not empty. Okay, there we go. This looks good. And now instead of harvesting, we're going to use the transfer function. Transfer, I think it takes first the type and then the container, if I'm not completely mistaken. Let's check really quick. ST, transfer, target, resource type, okay. So, not source. We call this container now. This should be let and not var. Transfer from container, resource, energy. And yeah, that's it. That's the lorry. There we go. Simple as that. We look for a container which is not empty, and then we transfer energy from it, and if it's not in range, we move towards it. And down, we do the same as the harvester would do. We just fill up the spawns, extensions, and towers. Okay, good. So now we have a lorry defined. Now that we have that, let's get some lorries going as well. So we copy this, make a lorry. Go. That was stupid. Anyway, lorry. Why do I copy? Anyway, so this is a lorry. Now we have to tell the game to spawn lorries. Okay, now it gets a little bit tricky again, because I want to change the spawn logic quite a bit. Okay, for preparation, let's first get the min number of thingy variables. So number of miners and number of lorries. Screeps in room, role is miner, role is lorry. There we go. Okay. So now we have those. Okay. Let's take a look at the old code. So in the old code, we would check if there are enough harvesters, and if there are not enough harvesters, we check if there are actually 0 harvesters. And if that's the case, we're gonna spawn one with whatever energy we have left. So this is basically the fallback if we lose all harvesters, because if without harvesters, we cannot fill up the extensions. So this is the fallback. We're not gonna use that anymore, because we probably don't want harvesters if we have miners. So, oh god, why is it fucking this up every time? I'm not sure what's going on with that. That's really annoying. No, wait, that's actually correct. But I don't know why is it doing this? This is really strange to me. If I use auto formatting, it will do that every time, and I'm not sure why. Yeah, strange. Anyway. Probably fucked up a few other indentations as well. There we go. Indentations. Weird. Yeah, I'm not gonna fix those right now, but anyway, so we don't want that anymore, but we're gonna keep the rest intact, I think, for now. Well, actually, we need, well, no, let's do that later. Okay, so we're gonna put the fallback logic at the beginning here. So we're gonna put the fallback logic here. When do we need to have a fallback? When do we have a fallback situation? Well, if we don't have any harvesters, keep in mind the code has to be working for rooms which use harvesters, has to be correct for rooms that use miners and lorries, and it has to be correct for rooms that use both. So the error situation, the fallback situation, is when we don't have any harvesters and we don't have either no miners or no lorries left. So let's write the condition for that. If number of harvesters is 0 and number of miners is 0, or number of lorries is 0. Because if either the miners or the lorries are gone, then we cannot produce energy anymore if we don't have any harvesters. So now there are two different situations. Either we want to spawn a harvester or we want to spawn a lorry. Because if just the lorries died, but we still have miners, then we can just spawn a lorry and we should be fine. So what we're going to do is we're going to check if there are miners left. If number of miners is greater 0, in that case we're going to spawn a lorry. So spawn, oh, we don't have spawn code for the lorry yet. Let's do that really quick. It's fairly similar to the custom creep, but not quite the same. So create lorry. It takes energy, it doesn't take a role name. The lorry wants to take one move part for every 2 carry parts, and it doesn't need any work parts. So move and carry both cost 50 energy. So 2 carry and 1 move part cost 150 energy. So we calculate number of parts with 150. Then we don't add any work parts. We add the number of parts times 2 carry parts, and then we add number of parts move parts, and then we have a body. Undefined role will be lorry, and the rest will be the same. There we go. Okay, easy, cool. So back to the main function. Create lorry with whatever energy, with whatever energy we have left, because this is the fallback situation. We have to spawn a lorry now, or we will not get any more energy anyway. So this is important. If we don't have any miners left, then we're gonna do the fallback and spawn a harvester. So we're just gonna do what we deleted earlier from here. Actually, not energy. That's wrong. We want to use spawn.room.energy. Energy capacity. No. Spawn.room. Wait. Let's check really quick. What is the... There's a variable called, I think, energy available or something? I think it's in room. I'm not sure. Room, energy available. There we go. Yeah. It's just not showing up in the autocomplete for some reason. Where was I? There. Energy available. There we go. And we're gonna do the same here. There we go. So if we don't have any miners left and no harvesters left, or other way around, we have no harvesters and no miners. No harvesters and no lorries, but we have miners left. We spawn a lorry. We have no harvesters and no miners left. We spawn a harvester, because the harvester can work on its own. So we just do that in this case. Okay, now we have the fallback situation done. Now we're gonna do an else around, well, actually everything, really. Well, we can just skip it here. It's fine. We could do the else, like we could capsule all of this in the else branch, but it's enough to just keep this one, because it will actually set the name variable if we do it correctly anyway, so it will not be undefined anymore, so it will not go in here anyway, so this should be fine. Is that good? I think that's good. So we check this. Okay, the only thing missing now is we have to spawn lorries in general, so we're gonna do that right here and after the harvesters. Else if, actually we just copy. If not enough lorries, number of lorries is smaller than min lorries. Create not a custom creep, but a lorry with the energy. There we go. I think that's it. Let's save. See if we get errors. Okay. Can I read property energy of undefined? Lorry 41. Lorry 41. Okay, let's take a look. Why is it running lorries anyway? Do we have lorries already? Apparently. We should not. Well, maybe. We probably should check if containers actually defined. Wait, 41? Find closest by path. Find structures. Filter. S. Wait, energy of undefined? What is this? I'm confused. There's no dot energy in this line. At roll.lorry 41. I'm on the right branch. Okay, I screwed something up. I'm not sure what though. Little confused. Cannot read property energy of undefined. But there is no energy in this line. And it clearly says at filter in lorry 41. Oh, it actually. There's no dot energy in here in general. This whole file doesn't include that. Okay, now we got something else. Weird. It just changed the error message. Number of harvesters. Yeah, that's a typo. Number of harvesters. Okay, what does it do now? No, it's actually running. Well, that was weird. That was very weird. I'm not sure what was going on with that. Anyway, what we have to do now is change some variables, because we want to get rid of all the harvesters and replace them with lorries. Actually, oh wait, I forgot something. I don't want to spawn lorries at max size. That's actually stupid. Let's do wait. It takes 150. Actually, probably 300 is enough. Let's try 300. That's four carry parts already. That should be fine. I don't want lorries to be too big, because I want to have 2 lorries. The reason for that is, so basically I want to have 2 lorries in every room. I'm not sure if 300 is correct. We're going, like, you have to play around with it a little bit and see how well they are doing, if they carry enough energy to fill up all your extensions quick enough. Basically, I want 2 lorries, so it's less likely that I run out of lorries in general, because that's a situation you want to prevent. That's actually with the harvester code. That's a similar situation. I prefer to have 2 harvesters. Problem is, if they are too big, and there are too many harvesters, then they will just deplete your sources really quickly. So that's not worth it either. So it's good to have multiple small creeps sometimes instead of one big one. They're in general, they're as efficient. Like, they have the same efficiency as one big creep. They will just eat up a little bit more CPU resources, so you have that, but that's not too big of a deal. Min lorries to, did I write this correct? Type this correctly, min lorries 2, yeah, okay, looks good. So we changed that everywhere, min lorries, there we go. We save, and that should hopefully spawn us some lorries and stuff. No errors so far, that's good. There we go, we spawned some lorries. Cool! Seems to be working. Oh, no, there we go. There's the error again. The fuck is that? What is this? How is that a thing? Did I fuck something up in my file names? No. Roll.lorry. It clearly says roll.lorry line 41, but I don't get this. What the fuck am I looking at? It's very strange. Okay, let me take a look at my old code and see how I did it there. Is there something else here? Oh yeah, I did this a little different there. Look for container, does find click path, structure container, and store energy is. I'll actually check for container is undefined. So I have a. Oh, the message is actually called withdraw and not transfer, so that's important. Good that I checked that. And I checked for if the container is undefined. Well, I guess we just add that. Why not? Doesn't hurt. So if the container is not undefined, then we withdraw from it, not transfer. We don't want to transfer to the container. We want to withdraw from it, obviously. Maybe that was the error, actually. And probably the error message is just not very clear. But I think what happened, it showed the wrong line number, though. I don't know, weird. It still says the same error, though. So this didn't help at all. I mean, yeah, the error is in this line. So I didn't change that. So look for container. This pause, find closest by path, find structures. Creep pause, find closest by path, find structures, comma. Filter as structure type, structure container, and as storage resource energy greater 0. Let's fucking copy this. I don't think that changed anything, but there we go. Source is not defined. Roll 47. Oh yeah. Okay, so I probably had a typo in there. I'm not sure. There was probably a typo somewhere. I'm not sure. Maybe in structure type or something. There we go. Okay, now it seems to be working. Weird. Not sure what was wrong. Probably, as mentioned, probably a small typo. Ugh, fuck, pulling the cable off my microphone again. Not optimal. Okay. I think we're good. So, let's take a look if everything is working as expected. So we have a container with a creep on top of here. That creep looks like it's a miner. The source is empty right now, so it's doing a good job. Oh yeah, we're missing one important part. Okay, we have the lorry. But now we have to tell all the other creeps to actually go to the containers as well and get energy from there. So let's actually copy this. Close those. We need to change the builder, the repairer, the upgrader, and the wall repairer. So instead of just wait, wrong files. Don't do that. There we go. Wrong branch. Again, the builder, the repairer, upgrader, and wall repairer. There we go. So instead of just looking for a source, we will first look for a container. And if we, that's why we have why this if condition was there. If we don't find a container that is matching the condition. Oh, it's also important because all containers could be empty. So yeah. So okay, if we're looking for a container, which is not empty, and if you find one, we go for that one. And if we don't find one, in that case, we're gonna do the old logic, which is look for a source and harvest that. So let's actually copy this. We do the same for the builder, the repairer, the upgrader, and the wall repairer. Yeah, the columns are incorrect. Don't care right now. I'm gonna fix up the comments before I upload the code to GitHub. So that should be not a big deal. Okay, I think we're good now. I hope we're good. So let's take a look at that again. So short reminder, the lorry is looking for a container which is not empty and tries to withdraw energy from that container. And if it doesn't find one, it will just not do anything, because it doesn't make too much sense for the lorry to harvest, because it doesn't have any work parts. So it cannot even harvest. So it only can go for the container. The builder, on the other hand, however, has work parts. Same goes for the repairer, the upgrader, and wall repairer. So they can harvest if they don't find a container. So they prioritize containers by looking for a container first. But if they don't find one, they will look for a source and just harvest the source. That's important, again, if you have a room without miners, because you don't do container mining in this room, or without containers, I should say. Or because your miners are all dead right now and are not actually mining and stuff like that. So this should work, and let's take a look. So, as mentioned, we have miners here, so these seem to work. And we probably have a lorry over here. No, that's not a lorry. Maybe this one? This looks like a lorry. There we go, that's a lorry. And that one is probably going for this container now. Let's take a look. There we go, it withdraws energy from the container. And it will actually wait until it is full. So it will sit there for a while the miner is harvesting energy. And the other creeps will do the same. They will go to the container, pick up the energy, and do their job. So, seems to work. Cool. Awesome. So this was pretty lengthy and fairly complicated. I hope I explained everything in a way that it makes sense. This was actually, I was a little scared before starting this episode, because that was definitely the most complex one I did so far. And, or most complicated, maybe. The multi-room one was pretty complex as well, but everything in there was pretty easy. So I was sure I was pretty confident I could explain all of it fairly well. And I was a little bit more scared of this one, because this is a little bit more tricky of a concept to get right. But I think I did it. Hopefully. If you have any questions, let me know. I was a little nervous before we started recording, but I'm pretty happy how it turned out now. So as mentioned, next episode will hopefully be about storage usage, so we can actually save up some energy and not just pump it into extensions. You should probably do all this stuff way earlier. Like, I'm on room level 7 now. No, 6 actually, but you should have this stuff probably set up earlier than I have, but I don't have too much time to play this game, so the rooms are running suboptimally for a while and just crate up over time. So yeah, it's probably more optimal to have this stuff set up earlier, but that's the order I chose for this series because I felt it makes sense. I'm not sure. It's not, as mentioned multiple times, this is not the perfect way of doing it, not the optimal way of doing it. This is one way of doing it, and it's one I chose for being hopefully easy to understand. And yeah, there we go. Next one about storage, and then one afterwards will probably be about refactoring my code, because it's got pretty clumsy now, and now that I have a better idea where the code is going and which direction I'm going with my code, I want to change some things up and make them more easy to understand and more easy to extend and more scalable and stuff like that. So that will be the topics for the next 2 episodes. I'm really happy that you guys watch my shit, or my content, I should say. I should not call my own content shit. That's not great. Anyway, so I'm really happy that you watch my videos. That makes me really, really happy that people spend their free time watching my stuff. So yeah, thanks a lot for that. Have fun and see you next time.